Hi, everybody. This is a quick video on constructing histograms. So, a couple of things. First of all, this video I'm going to construct a histogram by hand, which is ridiculous. There, you know, we will see so many histograms and statistics, and they were all going to be constructed by computers, almost all of them, right? I guess there are reasons now and again to do it, but I always like to begin by constructing things by hand with simple data sets so we get a good idea of what's actually happening, right? When the computer does everything, we might miss some of the finer details. So I'm gonna go through this a little bit, and then I'll do another video, a separate video where we do it with a spreadsheet program so we can do it some more sizable data sets, right? We don't want to be counting things by hand, and we'll let the computer do it for us. So I'm gonna use you might remember seeing something like this in a previous video. This is a frequency table that we built in the video on frequency tables. Histograms are visual representations of frequency tables, okay? So let me just remind us quickly of what happens with a frequency table, what everything is. So I made up some data for this frequency table. Maybe I'll show you the original here. This was the one we went through last time. I had this list of data that I had just made up. We computed the frequency that we call F is just how many times does each piece of data appear. So for instance, the data value 9 shows up just once, right? Or the data value 13 doesn't show up at all. The data value, let's pick 12, shows up a whole bunch. It shows up 9 times in there, right? So the frequency tells us how many times the data values show up. Then this total is n. So we often use n to represent the total pieces of data, total number of data. And if we take the frequency divided by the total, we get what we call the relative frequency, right? In other words, what proportion of the data was each value. So the one value 9, right? 9 showing up once meant that 0.05, a proportion of 0.05 of the data was the value 9. Or maybe we can look at 12, 0.45, almost half of the data was 12, so 45% of the data was a 12. So the relative frequency tells you, the frequency tells you how much it appears, and the relative frequency tells you what does that represent, what proportion of the total data does that frequency represent, okay? So we're not gonna use the cumulative relative frequency, the last column in that for this. So I've recopied the table, at least the relevant parts here, right? So all we do with I've begun this histogram, it's a kind of a graph to represent this, the idea of this table visually. I've listed the data values across the horizontal axis. And this is always what we're going to do, data values across the horizontal axis. And then across the vertical axis, I'm going to represent the frequency. Okay, so I'm going to give it a little bit of thought. I noticed my highest frequency is 9, so I'm going to go ahead and go up to 10. So let me just do this. So I'm counting by 2s. Right, so now I've got a scale on there. I apologize, it's not perfectly straight. I've been stuck at home a lot. I don't have any great graph paper here, and so I just wanted to get this done. So all we do is translate the information here to our graphs. So above the 9, it's a histogram is a kind of bar graph, so I'm going to put a bar up to the frequency. 9 goes up to 1, right? The data value 10 has a frequency of 4, so I go up to 4. The data value 11 has a frequency of 2. 12 has a frequency of 9. That looks about right there. "13 doesn't show up at all. 14 shows up once. And 15 shows up 3 times. Okay. And that's it, right? So this is a little sloppy. I'm in an uncomfortable position for writing here. It's a little messier than I intended. But that's what a histogram is. It's a visual representation of the frequency table, right? So if I'm glancing at this, what I see very quickly, for instance, is that 12 is our dominant value, and everything else, all the rest of the data is kind of spread out evenly between the rest of them, right? It's pretty easy to see that clearly. After I do a histogram, a video on creating histograms with a spreadsheet program, I'll do one on just reading them. We'll get some examples of the kind of information we can get from these histograms. But for now, what we should understand is simply that the data values are across here, the frequencies are across here. This is a really easy thing to confuse, right? So if, for instance, maybe these were shoe sizes of people on a basketball team, right? So I surveyed some basketball team with 20 members and got all of their shoe sizes. So these represent shoe size. These are just numbers, right? And we don't want to confuse the two, right? There's nobody that has, or this doesn't mean there's 12 people with size 9. It's 9 people with size 12, okay? One other small thing to do, just to mention, we won't do this as often, but we could also make a relative frequency table. And it really doesn't change much about any of this, right? So let me do something a little bit funny here and change my scale. Let's go with by tenths. Yeah, 0.1, 0.2, 0.3, 0.4, 0.5. Right? So I've just changed my scale, and instead of this side being frequency, I've now made it relative frequency. And notice nothing else has to change. The value 9 should go up to 0.05, and that's exactly what it does, halfway up to 1/10. The value 10 has a frequency of 4, or a relative frequency of 0.2. That's exactly where it should be. And everything ends up in exactly the right place. When we scale things by 20, we're scaling everything exactly the same way. Their relative sizes, that's part of where that word relative comes from, their relative sizes stay the same. And so having a relative frequency table and a frequency table really gives you the same information mostly, right? If you wanted to know specific numbers on one or the other, you'd have to have one table or the other. But visually, they're going to be exactly the same other than this scale. We will mostly do frequency tables, but sometimes we might be looking at data, looking at an article or something like that that has a relative frequency table. And this is what you should understand, that the shape doesn't change. And we're going to start getting good at reading the shapes of these graphs to understand something about what it means. Okay, that's it for the histograms by hand. I'll see you in the next one.